These are some of the examples of mathematics problems that we normally came across asked by your kids. Now, for example, you have what plus what equals 11. For primary one students, this might be quite difficult for them because they are used to add, for example, 2 plus 3, and they get the answer very easily. Or even you have 9 plus 2, you can calculate quite easily. But here, your kid needs different kinds of thinking, where they have to think in many ways to arrive at the answers. For example, your kids find difficult to get answers, the question should be find as many ways as possible to get answers. Okay, now your kid find difficulties in solving this type of problem. What you need to do is to get a plate and put it here. 11, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 marble, for example, anything that they can hold, can feel. So you take out one out, and then first you ask him, make sure that he counts and got 11 here. Then ask him to take out one marbles. So then ask him to write down the mathematical equation for this. All right, so now ask him to count how many here left. So they make sure he counts correctly and get 10. And 10 is inside, and outside you have another one. So 10 plus 1 is still the same amount of marbles here. And make sure that he knows exactly that there are 11 marbles here. So 10 plus 1 is equal to 11. Then you take out one more. See? Ask him to do it himself. So what is left? Ask him what is left here. What is being taken out is 2, right? But ask him to count how many left, right? So, after counting, you got 9. So 9 plus 2 equals 11. This has to be done by your kids, not you, as parents. Let them do the solution, the writing. You guide, right? As parent, we guide. And do the same thing, take out another one. So take out 3 there, ask him to write 3. Then what's left here, ask him to count. So he gets 8. But now he could see the pattern already, so he should be able to figure out. You take out one more 4, then perhaps this one become less and less. Or still, if he can't figure out, then you have to ask him to count. So 7 plus 4 equals 11, until he gets as many ways as possible, like 6 plus 5 equals 11. So these are the various ways of getting 11, tell him. And this kind of thinking, where your kids look into several ways of solving problems, is called creative thinking. You are developing creative thinking. It's creative thinking. It's called creative thinking. Creative thinking in mathematics. Creative thinking in mathematics. All right. You can also do the same thing with other questions, like you can develop your own question, like what times what. For maybe year 2, what times what equals to, for example, year 2 students. You might ask what times what equals to 12. Several ways of getting what times what equals to 12. So that this kind of questions, and we'll also develop creative thinking. Or what divided by what equals to 5, for example. So this might be suitable for primary 3, 2 and 3, where they learn about multiplication and division, right? Okay, now how about this? This is quite a different kind of problem where you need to guide your children to have a different kind of thinking, right? So I hope you have a better idea of helping your kids in solving these kind of problems, or this one, or this one. And initially you need something for them to hold, like marbles, concrete things. Then you go into semi-concrete later when they are very used to or they already got some understanding. So you may use mob, just draw. It's just draw. Now 10, say this is 11. So you take out, you cancel one. So you put one here, one of these dots here. So ask you to count 10. So get here 10 and plus 1 equals 11. To write down there 10 plus 1 equals 11, and again you take out this one, put another one here 2. So ask him to count again, and then you will develop that kind of pattern as what we did in where they can have concrete things to hold, right? This is semi-concrete where they can use diagrams. Later on they go into, once they are very used to it, then they can use straight symbols. So before they can really understand symbols, that you need to expose them to what is called here visual thinking, where they can see, they can feel. This is visual thinking. This one they use not only visual, they can feel. This one is visual, and this is later on they know, oh, mentally 10 plus 1 is 11, 9 plus 2 is 11. Or you can also change that to from 11 to 12. And in many ways you can develop questions for them to think, right? Okay, of course, like number 2 is slightly different. This number 2, you can guide them through still higher order thinking, like this one. This is one form of higher order thinking. Creative thinking is a form of higher order thinking. So this one, there are 2 ways in which you can guide your children. One is, imagine telling your, tell your okay, for example, your son, for example, having problem to solve this mathematics, this simple arithmetic, in fact. But not as simple because they can't figure out what is this blank space there. Of course, you can tell some stories. Okay, you go to the shop, you want to buy, say, a thing which costs 54 ringgit, but you have only 27 ringgit. So what do? How is 54 and 27? Say, of course, they can make a guess like 54 minus 27, or 27 plus 54. If they say, ask your son whether to minus, or if they minus, and then let them calculate, and then you get 27 there. Okay. If they say they plus, okay, 54 plus 27. And let them got the solution there, 1 and then 81. Okay, all right. Tell them, what do you think will be the answer? You minus or you plus? They say plus. Okay, you put 81 there. 81, you ask him to check whether 81 plus 27 equals to 54. And then ask him to try. What about 27? 27 plus 7, is it equal to 54? If he says yes, that is the right answer. See, this is one way. where you see the logic is there. Train them to see logic is there. How can you have 27 ringgit? You want to buy a thing of 54 ringgit. Suddenly you have to add 81 ringgit to 27, which is more than 54 ringgit. That is trying to develop logics and also common sense. But there's another way besides using common sense and logic there. What you can do is, let's say we try to figure out another way of doing it. One other way is to, let's see, like for example here, we have, now, it is easy if you compare or you make the number simpler. Instead of using 27, put number 1. Instead of 54, put 3. I suggest use 1 and 3. So the bigger number 3, put at the bottom of the bigger number in the equation given here. And the lesser number, 27, you put 1 under that lesser number. And then ask him to rewrite the equation there. Okay, just follow whatever has been written up there. So here, ask him what is the number when you add 2 1 you get 3. Of course, they can figure out easily. 2 plus 1 equals to 3. So now, ask him again. Okay, what do you do to get 2? Now that you have said 2 plus 1 equals to 3. Now ask him, okay, what do you do with 3 and 1 to get 2? Okay, he says plus, 3 plus 1 equals 4, but here is 2. So we will say minus 3 minus 1. So ask him to put minus sign there. Now that these two numbers, these two numbers and these two numbers, they are similar here, meaning that on the right is bigger number, on the left smaller number. This is on the right bigger number, and on the left of the equation, this equal sign there is smaller number. They are quite similar in the sense that the right number is bigger than the left number, where the equation there is the boundary. So here we have the right number bigger than the left number. To get this number, you take 3, the right one minus the left one. So likewise, because they are similar, these numbers, they are similar, then what you do, tell your kid that if you minus 3 right minus left, here you should do the same thing, right minus left. So 54 minus 27, you get 27. This is what you call analogic reasoning. By comparing now that they find difficult to imagine big numbers, what plus 27 equals to 54. But you say instead of 27, you say 1, which is very much smaller, and 54, which is much smaller, but it's bigger than on the left, like here, bigger than on the left, but smaller. So easy to figure out what to do with the numbers. So again, I repeat. So first, you put 1 under the smaller number. Put 3 under the bigger number. The bigger number is on the right, and the smaller number is on the left. So see, and then put equal sign plus. Just follow whatever has been written here, and then here blank here. So ask your son what number is to find out what number should you put if you want to get 3. So 2 plus 1 equals 3. So now again, you ask your son, how do you get 2 by this 3 and 1? So of course 3 minus 1. So if it is 3 minus 1 at the bottom here, therefore at the top here should be 54 minus 27. Here 3 on the right minus on the left, and here on the right minus on the left. So this is called analogic reasoning. This one way where you can help your children to see. Yeah? But of course you got to give several questions, not just one question. Several questions of this type. Give more examples and keep on explaining, guiding him or her to get used to the analogic reasoning here, right? Like for example here, okay, instead of 1 to 9, you put 1. Instead of 6 to 1, you put 3. The bigger number is 1 and 3. Use 1 and 3, very simple. See, a smaller number is 1 to 9. The bigger number is 6 to 1. So the bigger number, you put 3 at the bottom there. And for the smaller number at the bottom, you put 1. You see? Now just rewrite the equation and put back there, equal sign. And then you can ask your kid, okay, 1 plus what equals to 3? So he says 2. Okay, how to get 2? Using 3 and 1. What else? What is supposed to do? 3 minus 1 or 3 plus 1? Of course, he will easily figure out that 3 minus 1. See, 3 minus 1. So what do you think at the top there? Should be 6 to 1 minus 1 to 9 or 6 to 1 plus 1 to 9? So of course, you take the right minus the left. Here we get right minus the left. Initially, your kids might find difficulty, but as you keep on telling, give few more, 3 or more samples, and ask him to work out this way. Put all these things as your solution, working solution, right? So that's how you work. And of course, using common sense. The price, say for example, a bag is 6 to 1. Now you have only 129 ringgit. What do you do? Or with these two, you take this minus this or this plus this. That one using common sense, right? Of course, your kid can't see because maybe some of them see it's too big a number. Say, what about asking them instead of 1 to 9, change to 1. Instead of 6 to 1, change to 3. Okay, 1. You have 1 ringgit or $1, but what you want to buy costs 3 ringgit. How much you need to add? That can be seen by kids, right? So you will know most kids will answer 2. If he answers 2, okay, ask him, how do you get 2 using 3 and 1? Do you take 3 plus 1 or 3 minus 1? So you say 3 minus 1. So you get 2. So this is using common sense. So you can use analogic reasoning and using common sense for this kind of problem. So you give several questions for them to adjusting places. Sometimes what is to find out on the left, and then sometimes on the right. And several questions. Increase the numbers as your kids goes to primary 3 and so on. But this is another problem. Might be this is not too much a problem for some kids, but this kind of problems here, where what minus what equals to 17, that might be a problem sometimes, or in fact most, through my experience, students find it difficult to figure out. But as parents, you cannot, because they are still in primary school, you cannot use equation like you minus 21, x what minus 21 equals 17, then you tell them minus become plus. Of course, that is right, you get right answers, but then it is not a proper way of teaching kids when they haven't got the idea of equations, because they are still in primary school, and also they need some reasoning here for us parents. What might be is very simple. There's not much thinking to be done for them, but for them they need some thinking. That's why the level of the level of knowledge influence whether one has to think to solve a problem or it becomes a routine. For your kids, is It needs thinking. You need higher order thinking. All right. So let's say again, you can use the same approach. For example, you can, of course, you take rewrite the equation. You can rewrite the equation become what minus. Again, the smaller number, this is bigger. This 21 is bigger than 17, so you take 3 and put on another 3 and ask your kid to put 3. For 17, and then ask your kid, what should I put? 1, for example. So ask your kid, what number, when you minus 3, you get 1. Of course, they can figure out easily. They say 4. If they found it 4, then ask him again how to get 4 by using 1 and 3. Forget about the sign, but using 3, forget about the sign. 3 and 1, what do you get? 3 plus 1, or 3 plus 1. What do you think will be the solution for the top equation here? This is smaller number, this is bigger number. This smaller number and bigger number. To get this number, what you did was you add 1 to 3. So in the same manner, what do you think you will do? You will do, all right? So of course your kid will get the idea that this is also right minus right plus left 21 plus 17. Okay, so that should be 8, 38. And then to see whether the answer is logic or not, try to encourage your kids to check the answer by taking 38. Taking whatever been solved here, like for 38, ask him to put 38 there, check whether you get 17. This is another way of making them confident that they got the right answer. Here the same thing, you have 26. Again, you can use the same approach using analogic reasoning, where analogic reasoning means reasoning by comparison. You see, sometimes, in fact, more often, when our kids solve problems using bigger data, big numbers, they cannot figure out. But when you simplification of data, when you simplify data, this is a form of thinking, because is a form of analysis. It's how your kid do analysis of a problem of this kind. For example, making this problem look simpler. That comes under inductive reasoning, which we'll learn more in the actual program when parents register for the whole program, which takes about 7 to 8 hours. Of the whole program takes about 7 hours of 8 hours, including activities that parents need to do together with the children. So this is just a brief explanation. All right, so here again, you ask your kid, or maybe your son, okay, this is 216, which one is bigger? So you say, oh, this one is bigger. What should I put? I'll put 1 or 3? Oh, 3. What about here? 1. Okay, then ask your kid. All this must be done by your kid. You just give instruction. Let them do it. Let them have the feel of mathematics. So ask him again. 3 minus what equals to 1? Oh, see, you got it 2, for example. Okay. Now ask him again. Okay, what do you do with 3 and 1 to get 2? Again, they will figure out, 3 minus 1 to get 2 here. So what about here? So trying to let them see some pattern. So it's about some pattern, spotting, analogy, reasoning. There's a pattern of answers where they solve the problem. Pattern of activities when they solve problems. Looking for similarities here, because of this big number, this on the left, small number on the right. To get this middle number here, you take the left number minus the right number. So same thing here, 216 minus 160. So you get the solution, 216 minus 160. And then after getting the solution, encourage him to put the solution here, whatever has been solved here. 6, for example, 3, 7, 6, 7, 3, 7, 6. Now here, you see, here you find that 216 minus 160. Yeah, sorry, this is 216 minus 160, because here 3 minus 1 to get 2. So here 216 minus 160, so 160. So you minus, you get 0, 6 here, you get 5 here. Okay, so you put 56. So after they put 56, ask him whether 216 minus 56 will give you 160, for example. So you question him. Depends whether your daughter or your son. If it is your son, question him. Is it true that 216 minus 56 equals to 560? So this is how you make them responsible for what they have solved, for what they have done to solve a problem. Okay. Now that's all about these are some of the questions, but there are many other questions which we can discuss in the actual program. This is just an introduction, and of course here. Let's say we go to the next part of the question. This is the one I think is meant for standard 4 or standard 5, primary 5. But these are some of the simple problems. Since the introduction of new format in GPSR standard 6, the question is more challenging. But this is just a basic question, but still needs higher order thinking. For example, coming across this type of questions, the tendency for some parents when their kids ask them this type of question, is to say that, okay, simple, you take 4,000, and then you multiply, you invert this one, 2 over 5 become 5 over 2. This is very bad. This is not going to help your children to think. Of course, you can get solution for this. You can get, say, 2,000 here, so you get 10,000. To 5,000 to 10,000. Of course, you get the right answer. But this kind of solution, that you don't get your, it doesn't help your child to think, to reason. We want them to reason. When you may develop a higher order thinking. Okay, example of higher order thinking is critical thinking, mathematical thinking. When you want to develop this kind of thinking, you need to train them to reason out, not just doing it mechanically. This is one method, but this is called rote learning. You're introducing rote learning. This is not good for your kids, because it won't help your kids to be creative, critical about mathematics. And of course, as I said, if given more difficult problems, then your kid will find difficulties if he is not being trained to think critically and creatively, right? Okay, if I were you as parent, I would say this. I will train him to analyze the problem. How do you do it? Okay, suppose you're teaching your daughter. Ask your daughter a question like, what is the meaning of 2 over 5, for example? So he might say, 2 over 5 is a fraction, or 2 over 5 is 2 per 5. Maybe she translates into Malay language, whatever. But tell her that 2 over 5 means 2 parts out of 5 parts. The whole parts is 5 parts. Make them understand that the 5 here, the denominator refers to the total number of parts. So tell her that the whole income is 4,000. So we can try to represent how much income in a different form where you can easily understand what the situation, what the question is all about. For example, one way of representing this question in a simple way is to ask your daughter to draw a straight line, okay? And then divide into 5 parts. Divide into 5 parts. 1, 2, 3, 4, 5 parts, okay? Now what do you do? Tell them that we have, let's see, we'll draw again. All right, now, okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Okay, you can ask your daughter where is the 2 parts. Or tell your daughter that we represent the salary, how much salary as divided into as 5 parts. Let us assume that how much salary is divided into 5 parts, because 2 over 5 of how much salary for January is 4,000. So this is the whole salary. This is the whole salary, right? Now, 2 over 5 means 2 parts. So tell your kids to draw this. You don't draw, but you let your kid draw this. Let your daughter draw this. All right. Now, what else? What other information given? Okay, 4,000. This 4,000 represent. Ask her, where should I put the 4,000? Where should she put the 4,000? Is it here? You have to question your daughter or your kids. Or is it here under 205? Some may say here. If they say here, why? You put 2 over, put here as 4,000. Why? But the question says 2 over 5. Are you sure it's here? That is how you pose questions to her. Of course, after that, she will understand or realize that it should be here. You make her realize that it should be here. You don't just say, oh, you put here, 4,000 should put here. Don't. You have to keep asking while you explain. It's good questioning. So when you question, you develop what's called metacognitive skill. The skill of being aware of what he or she is doing in mathematics. Thinking about thinking. So he's thinking what he thinks. So awareness, simple word, metacognition is awareness of what one is doing in solving mathematics problem. In the case of mathematics. Okay, 4,000. So then you proceed. Okay, ask her to write down. Okay, 2 parts. You can write down 2 parts. 2 parts of the journey, which is equivalent to 2 over 5, is equal to 4,000 ringgit. So to find the whole part, 5 part, what do? You keep on asking questions. What do you think you should find first before you find the whole parts, 5 parts? Or after giving enough thought, probably your daughter come up to saying, oh, find 1 part first. So 1 part, which is 1 over 5, equals to, even if you don't have to write to 1 over 5, you just say 1 part, say 4,000. Okay? Then you might say, oh, divided by 2. So she gets 2,000 ringgit. Okay, where do you put the 2,000? Ask her again. Oh, yeah, it's 2,000 here. Can I put 2,000 here? You ask her again. Oh, yes. Sometimes they might try to figure out, is it right or wrong to put here 2,000. Then or ask you to put all those 2,000 in. All 2,000, every part is 2,000. So ask her again, what do you think will be? Now what do you think? What is the whole salary? So you just add up. Adding up to get 10,000. So in other words, first you take 4,000 over 2 to get one part. Then what do you think? Instead of adding up, all these things, 2,000, 2,000, 2,000, you will multiply by 5. This one gives one part, which is 2,000. One part is 2,000. Therefore, 5 parts times by 5. So your kids will understand why he has to multiply 4,000 divided by 2 multiplied by 5. Instead of 4,000, then you invert, you get 5 over 2. That is the reason why we need to teach them what is called higher order thinking approach, or developing higher order thinking skills before, in the process of solving a mathematics problem. So here your kids not only learn about fraction, but also learn about critical thinking, and creative thinking because she is able to see two ways of solving this problem. One is through addition, 2,000, 2,000, 2,000, 2,000. The other one is through multiplication. Once you get one part 2,000, so he just multiply by 5. So the whole part, so you can say the whole part, the salary is equal to, if you notice that one is 1,000, one part is 1,000, so 5 parts 5 times 2,000, which is 10,000. So this is one way of showing the working, and if he's very well versed or she is very well versed, so you can figure out very easily, I want to find one part which is 4,000 divided by 2, and after that, once I get one part, after 4,000 divided by 2, I will multiply by 5. So that's how thing goes when you equip your daughter, your children to think. Okay, so I think these are some of the hints or some of the examples that I can give to all the parents, so that parents will see that mathematics is not just about getting answers, but also to get answers in several ways. At the same time, mathematics is a tool where your children can learn higher order thinking. So two things here that you can develop. You develop understanding of fraction, a deeper understanding of fraction, as well as teaching your children higher order thinking, critical thinking, and creative thinking along with the content. So I hope all parents will register for the full programs. The full program will take about 7 to 8 hours, plus activities. You bring along your children. This is through e-learning program. This is an e-learning program where you can just sit down at your laptop or tablet or a computer, and you can learn together with your kids. Or you want to learn yourself first, then after that you want to call your kids to give it a try. So you can always pause the program. Whenever, for example, here, there's a question here. First, you can ask your daughter or your son to try first. And then after they find difficulties, okay, then on the video and let your child or your children watch together the explanation. The same thing with this question. Let them try and then pause the video. Then that's how you learn together. You help your children to learn mathematics, be with them together, and they find it very interesting when the parents are also very interested in their learning process. Okay, so please register right now to join the whole programs. We have e-learning program where you just sit at the computer and you can sit at the tablet. You can sit at your laptop, and you can have this program in front of you. Besides that, we have also webinar programs. Same thing. We'll have two types of program. One is e-learning, where you can start from certain dates mentioned, and the other one is webinar, where you listen to me live, talking to you, and you can also perhaps call, respond, and we'll communicate. Right. So good luck. Wish you a happy day and happy life. And I think life will be more interesting if we see our children grow and think skillfully. Thank you.